Okay, so I had a preamp that looked like this and it worked. Way! But it was a bit prototypey. So I thought, let's use a cheap CNC machine and free software to make some PCBs whilst drinking beer. Great! You start with a circuit diagram. You might have to redraw it tidily with the parts laid out how they'd work on the actual circuit board, with your connections where you'd want them on the actual circuit board, and then draw the board outline around it at the correct aspect ratio. My board is 60 by 30 millimeters, for example. We'll make our circuit boards, or PCBs, out of single-sided copper-clad board. Where your circuit nodes are, that's going to be copper. The different nodes will be different areas of copper. We'll draw lines between the different areas of copper and cut these lines out with a cheap CNC machine whilst drinking beer. We'll use a free 2D CAD program like NANOcad to design the layout of the lines. Okay, so in NANOcad there's a layers dialog under Format Layers, and in this dialog here you can turn visibility of individual layers on and off, and you want them all turned on, because what you're going to do next is to select everything that you've just drawn out and you want to mirror it, and you do that by going to Modify, Mirror, just like that, and then you tell it the start line and the end line that it will mirror around, and then down here in the bottom corner you will see it prompting you to see if you want to delete the original copy, and you say yes, Y, enter, and there you go, you've done it. And now you'll see here I'll bring up where's the hand tool, there we go, grab it, move the thing across, and that is the thing that you've just mirrored. So that's the mirror image of what you have prepared earlier on. Now you're now looking at the bottom of the circuit board, perfect for when you're going to mill it out of a piece of copper. And next, of course, you want to save it, so save as, and we're going to go to the DXF format, which is what we want to do if we're going to make G-code, and we're going to go for one of these formats down here, 2010, something like that. Try a few of them, one of them should work. Type in an appropriate file name down here, I'm not going to change this at the moment, and go to save, and tiddly pom, you'll be flying. So, having exported your stuff from NANOcad as a DXF file, you would then load it into DXF2GCODE to generate your G-code. And I already have a project, what I have made for the board that I was working on, and I've got it on C drive somewhere. Yeah, it's in my documents, and it's a project D2G. There you go. So this length of some elements too short, length must be greater than the tolerance, skipped geometries. I have no idea what is causing that, but it did that when I first loaded in the file. Now this is the project for that board, and it's not the raw form of the thing that it first was in. So basically this is after I've worked on it a while. But there you can see what happened was it loaded in first of all the components, and there's the components, there's the outlines of the capacitors, that's the transistor, there's the capacitors. Don't forget we're looking at the underside of the board here, because I've mirrored the board, so we're looking at the copper side, because this is the side that we're going to use a milling tool on, or an engraving tool rather, to cut out these gaps between the separate sections of copper. But we don't want it to cut out the circles and things to show where the components go, so I'm going to leave those out by unclicking it in this pane over here on the left. But all of these sections we want, and the reason that you have these things highlighted like so is when it first imports it, these are not in this order. You can see the order that the shapes are in, and there are various options in the setup for this software regarding optimization, and in my experience, you have to turn a lot of that stuff off because it generated corrupt G-code which had lines going across it, which were basically errors, incorrect G-code. It sent the tool to the wrong corner of a shape and then milled it out. And then the tool wasn't in the place it expected when it moved off to somewhere else, and it created errors in the output. So I'd had to turn off a lot of the optimizations to get the thing to make the correct shapes. So with the optimizations turned off, I then found it had jumbled up all these shapes, and it had all the shapes and holes all mixed up. But what I've done is I've gone through, I'll just click through them in order now. Here we go. So it will first of all do that one, and then that, and then machine that, and then machine that. So I've just clicked on these things and moved them into position. So if, for example, I wanted to change the position of shape number 57 in the list, I would click on up or down to move it up. I could, for example, move that up to the top of the list, so that shape 57 would be done first. However, I don't want it to do that, so I'm not going to press save when I finish this. And basically, if you look at the holes were jumping about randomly in any order, and what I've done is I've got it doing the holes in the following order. If you watch the holes in red, you'll see them sweep around the board and then back again as I click around like so. So that's the order in which it will engrave the centre of the holes, which I then drill out using a Dremel. But at least I have a proper little mark in the centre of the hole as a pilot to show me exactly where the hole ought to be. So basically that's the process, and once you've done that, you go to export shapes, and it generates a G-code file. Now in the options, I think it's in the configuration. Some of this stuff down here, somewhere down here, there's some settings where you so you tell it the height that the tool should go to and how deep you want it to go to and cut and so forth. So when I'm engraving a circuit board, for example, I tell it that that I only wanted to go down to 0.5 millimeter deep, and I wanted to do it in one go. For example, if I wanted it to do several successive cuts going down 1 millimeter at a time, I would set that to being -1 millimeter, and if I wanted to go down to 5 millimeters deep, I would set that to -5 millimeters. Then it would do 5 separate cuts down these jobs, down these cuts, until it eventually got to the right depth. That's the height that it goes to when it has left the workpiece and gone back above the workpiece to a safe height, and then that's the height that it goes to before moving across the workpiece to a different position to start the next cut. So I'd be changing those down considerably. And somewhere else in here is a setting where you tell it all the G-codes that it needs to insert at the start and end of your job, which I discovered when I started making these boards is entirely incorrect for my exact needs, and I need to do a quick edit on the file before I use it. Basically, you have to play about with these settings a bit to get it to do exactly what you want. This stuff here, ordered, I had to set these as they are here before I got sensible G-code out of this software. This is completely free software. God bless the people who make this, marvellous people. It costs a lot of money to get software which does this job, if you're going to actually pay someone for some software, but this is free, so I'm very grateful to have a piece of software which does this for free. There you go. So you would do the export job and then you would load it into something like Chemotics, which we'll cover next. Let's do Chemotics. Start a new project. Add the file. G-code. Let's go to projects. Set up the tool. Set up a very small tool because it's only a fine circuit board that I'm doing, and I'm going to change the default setting on this software, because if I don't set it to high resolution you can't see what we're doing. And here you will see the circuit board. Let's turn off the tool paths. And there is the output from the G-code file which was produced by DXF2GCODE. Now previously I had G-code files where I had some strange cuts which went back to the origin and from some features to the start of other features, which was errant behaviour, and I managed to get it to go away by turning off optimizations and forcing the software to always draw the feature starting at the start of the feature, and not to try to reorder them, and that seemed to get the thing to generate software G-code of the right form. So you'll see now that I've optimized the order. When I whiz this back, it should at least try to draw the lines first and then do the holes, so you'll see it do the outline. I won't play the whole thing, but you'll see the general sort of plan. It will whiz through, it will do the lines, after a while it'll do the holes. Etc. When I made these circuit boards, what I ended up doing was actually doing a global search and replacing the G-code and changing the height that the tool retracted to between cuts on these lines, changing it to being just above the surface of the workpiece, because this 15mm was very excessive for what was actually needed. But that's the sort of thing you learn when you do this. It's the first board I've made using this software, so that's what you find out. There you go. Can I click forward? Camotics software that you're watching on the screen now is also free. You can make a donation to the kind gentleman who's written this. It's very useful. It does produce weird output sometimes. There are a few G-code viewers online which also work quite well. I tend to find personally that if you've got a combination of different tools to use, a whole bunch of tools to try, if one tool doesn't work to do a certain job, you can always try another one. NC viewer is a thing that seems to work quite well. That's an online one on the web for viewing G-code. That seems to work quite well. So there you go, there's the board. There's the G-code. That's the basic plan.